The fundamental principle behind airplane takeoff is lift. Lift is the aerodynamic force that opposes gravity and allows an aircraft to become airborne. It is generated by the shape of the wings, specifically their airfoil design. Airfoils are curved on the upper surface and flatter on the lower surface. As the airplane moves forward, air flows over and under the wings. The curved upper surface forces the air to travel a longer distance, creating a region of lower air pressure compared to the lower surface. This pressure difference generates an upward force lift. However, lift is not constant and depends on several factors, including airspeed. At lower speeds, the airflow over the wings is not sufficient to generate enough lift to overcome the aircraft's weight. This is why airplanes need to accelerate to a specific speed before they can take off. This critical speed, known as the rotation speed or VR, is the point where the lift generated equals or exceeds the aircraft's weight, allowing the pilot to rotate the aircraft and initiate the climb. While the fundamental principles of lift and takeoff remain consistent, different aircraft types employ variations in their takeoff techniques. This is primarily due to factors like aircraft design, weight, engine power, and intended operational role. For instance, large commercial airliners with high wing configurations typically utilize a technique called a ground effect takeoff. During this maneuver, the aircraft lifts off the runway at a slightly lower speed than its optimal climb speed. This is possible because the proximity of the wings to the ground creates a cushion of air, increasing lift efficiency. On the other hand, smaller aircraft like general aviation planes or fighter jets might use a technique called a flat rotation. In this method, the aircraft lifts off the runway at a steeper angle and transitions to a climb more quickly. This is often preferred for shorter runways or when a rapid ascent is desired. Before an aircraft can even think about taking to the skies, a rigorous set of pre-takeoff procedures must be meticulously followed. These procedures are standardized within the aviation industry to ensure the safety and efficiency of every flight. Inside the cockpit, the pilot and co-pilot work in tandem, meticulously running through a pre-flight checklist. This checklist covers everything from verifying engine parameters and fuel levels to testing flight controls and navigation systems. Simultaneously, communication with air traffic control is paramount. The pilot will be in constant contact with the tower, requesting clearance to taxi to the runway, confirming takeoff instructions, and receiving information about weather conditions and any potential hazards. Once all pre-takeoff checks are complete and clearance has been granted, the aircraft lines up on the runway, ready for takeoff. The engines roar as the pilot advances the throttles, propelling the aircraft forward with increasing speed. As the aircraft accelerates down the runway, the pilot closely monitors the airspeed indicator, waiting for that crucial moment to initiate the rotation. At or slightly above the calculated rotation speed, the pilot gently pulls back on the control column, raising the aircraft's nose into the air. This pivotal maneuver, known as the rotation, marks the transition from ground roll to airborne flight. The aircraft begins to climb, and the pilot adjusts the elevator control to maintain a steady climb rate. The initial climb is critical as it establishes the aircraft's trajectory and ensures clearance of obstacles in the vicinity of the airport.